Okay, so this week is going to be kind of a follow-up video about what happened last week, and I'm going to try to keep this as brief as I can. But you might have noticed in the last video I was kind of concerned about the compression test numbers that I was getting out of this, and that they just seemed awfully low, and I couldn't explain why they dropped that much since the previous compression test, since the engine really didn't run hardly at all between that last compression test and when we did it, in the last video. It just didn't make any sense, and it just kept bothering me. And I thought about it for a day or two. What I did was I got suspicious of my compression tester. I went down and got a fairly inexpensive new compression test kit. And wouldn't you know, when I did the compression test with that, all of a sudden my compression test numbers are good. So why? What was wrong with my old compression tester? So that's what we're going to be going over today. So we'll start off. This is the compression tester that I used during the last video. And so we'll do the same thing again. We'll check the compression on it. Alright, so I'm reading just below 100, maybe like 99. And then, I'll just show you in real time. I'm going to remove this compression tester. And I will install the new compression tester. Let's see what we get now with the brand new compression tester. So you can see remarkably higher, right? And these compression numbers don't bother me at all. I think these are actually really good. So what does that come out to be there? Is that 150? I'm getting about, I'm going to try to go on the higher side and say 162. Let's go 162 on that. You might have remembered in the last video, I took this and I calibrated it against another gauge, and it was reading the same pressure. And the other thing I did off camera during the last one, because I was suspicious of those numbers, is I took this out and hooked it up to my Chevy 350 that I have in a car, and that's a known good engine, and I was reading 150 psi on the gauge. So I was like, okay, this thing must just have low compression because this thing's reading right. Or it's apparently reading right. Or at least it made me believe that it was reading right, because I checked it against another gauge and I checked it in a car. Now granted, the car that I checked it in, I'd never really done a compression test on that, so I didn't know what the compression number should be on that really either. But what I want to show you now is, this is the hose that came with the new compression tester. So we're going to use this gauge with the new hose. If I can get it on there. So let's see what happens now. And I'll try to... So hopefully you can see that. I'm reading about 100 and... I'll zoom in on that for you. If it'll focus. So now this gauge is reading 160 some psi. So what on earth could be different about that hose that's in there? And what I did was I took the old one and I cleaned it out. There was nothing in it, but I blew air through it. But of course what I had to do, what's in the end of this thing is what I'm pretty sure is called a a Schrader valve. I had to take that out and then blow air through there, and there was nothing in it. No dirt, no nothing. It was free and clear. So what could possibly be the difference between this hose and this new hose? Well, it's got to do with that Schrader valve. Now let's go talk about how it's causing this problem to happen. This one here is the Schrader valve that was just in this. So what I did was I measured about how much force it takes to open that, to get that valve to unseat. The amount of force it would need to do that is about ½ pound on this one. Now this here is a replacement Schrader valve that came with the new compression tester kit, so it's just a maintenance piece for it. And what I can see here is that this unseats with it's very, very little force required, much less than that one. So what it means is that the spring in that one is much stiffer than the spring in that one. So that's the difference between the two. And what we'll do is, before this is all said and done, I'll put this Schrader valve into this and do the compression test again and show you that, yeah, in fact, that is the problem. So that's the difference between the two. Now this one was specifically intended for this kit, and my guess is that this one here is probably intended for a valve stem core and a tire. That's probably what that one's from, or for. And then the reason why, how did the wrong one get in here over the years? Well, it's because I would use this to use the valve spring compressor that you use on the cylinder head to take the valve springs off without taking the cylinder head off. But to do that, you need to pressurize the cylinder with air so the valves don't fall in. But in order for that to happen, you have to take the Schrader valve out, or else it won't pressurize the cylinder. The air will just go into here and get trapped and not go into the cylinder. So that's why over the years I've taken this out and put back in, and I'm gonna guess at some point or another I put the wrong one back in. And the original one for this is probably long gone. So I have these ones here now, and we'll try that out next. So let me put that green one in here, and we'll check it using this hose. And the other thing I'll say is that this the compression tester that I've been using, I've had since the late 90s. So, you know, over 26 years I've had this compression tester. So this is the hose that we were using before and getting the bad readings with. And this is but it's got the green, it's got the appropriate Schrader valve in it. So everything's the same here as before with the previous test, except for it's got that green Schrader valve in there from the new kit. So let's see what we get in terms of compression now with that Schrader valve. And we're just above 160. So yes, I do believe that the problem I had everything to do with that Schrader valve. Now, I never would have thought that would be a problem, but it obviously is. So let's go to the whiteboard, and I'll try my best to demonstrate with a very crude diagram and some numbers what I think caused this and why it happened. So here's what I think's going on. And this drawing did not really turn out as good as I wanted it to, but it's just going to have to do. It's just going to have to do for today. So what we're going to be looking at here is, this is the pressure coming in from the cylinder. This is meant to be the Schrader valve here, and I did my best to try to draw what I think's inside of there. The compression gases come in here through the Schrader valve. They have to unseat that valve, go through here, and into this pressurized area where the gauge can read the pressure in here. What it probably is going on is that as the compression test goes on, basically at first this pressure just unseats this here, which takes some pressure to do that. It takes some pressure inside of this cavity here to move that part of the valve away from the body here so that it can unseat and allow gases to go through here and then into the gauge area where it reads the pressure. But as the pressure inside of here increases, you have pressure acting on this, and it acts like a piston, sort of. and this pressure here is forcing that valve shut. As the pressure in here increases, the pressure over on here needs to both overcome this pressure here that's pushing the valve shut, and it needs to overcome the spring force that's holding that part of the valve shut. Now, that is where I think the problem is that, remember we looked at the spring force on the Schrader valve that works is way lighter than the spring force on this other one, where I had the problem. So what I did was I measured the diameter of this orifice here in the Schrader valve, and I came out about 0.09 inches. And then what I did was I took the diameter of that and found out the area of that part of it, and it came out to be 0.00636 inches squared, roughly. That's about what it was. I don't have tools to measure something like that real precisely, but it's pretty close to 0.09 inches. And then the other thing I did was I used that scale that was in the background of the previous part, and I estimated about how much force I needed to push on this part of the valve in order to unseat that. So the force there to unseat this part of it was about 0.5 pounds of force. With respect to the force that the spring is exerting on this, you need a certain amount of pressure here to overcome that spring force and open this and allow the gases to come through. So to calculate how much pressure I need there to overcome that, we'll look over here. Pressure equals force divided by area. So it'll be pounds per square inch, basically. So we have a cross-sectional area of 0.0036 inches squared, and it takes about half a pound of force to open that, to unseat that valve. And I calculated that to be about 78.6 psi. So those numbers we were getting, that 90 to 100 psi numbers that we were getting last time, and today we got about 99 on the gauge with the wrong Schrader valve in it. What I think is going on there is that the pressure, this would be the pressure in the cylinder from, going into the compression tester. This is the pressure required to open the spring, and this is the pressure that we actually read in the gauge, so 90, right? So what I think the way this is working is that this pressure equals the pressure in the spring plus the pressure in the gauge. So if we look at that today, if we look at that with what we had today and see if this kind of like do a sanity check on this, we know that we got about 162 psi today, and if this idea works out, let's see, it'd be like 78.6 plus the gauge pressure, 99. And if you add those together, is this actually going to equal that? Well, probably not going to be exactly. This here would come out to 177.6, which doesn't quite equal, but it's off. That's a difference of 15 psi. That's what I think's going on. This number here might be this number here calculated might be off because this number here is probably not completely accurate, and that number there is probably not completely accurate. Let's talk about whether or not what happened here invalidates the test that I did last week. This is the data that we got last week. Is the test that I did last week and the conclusions that I came up with, do I still think they're valid? And my answer, or my position on that is yes. I still believe that my conclusions at the end of that video, they're still the same. I still think the same thing as I did before. And basically what my position on it was is that I felt like the oil additive improved the oil pressure as the temperature changed. I think it held that better. It seemed like it was a little bit better. The oil pressure stayed a little bit more steady with the additive in it than it did before. So obviously there's nothing about this that would change that. But the next thing I said was that I didn't think, based on this, I didn't think that it did much to help the compression. So there's two reasons why I'm going to stay with that position, is that I don't think it helped much with the compression if it did anything at all. Two reasons. One was I also had the blow-by numbers to go with it, and they didn't change. And really, in terms of blow-by, the data coming out of the blow-by meter probably means more than the compression numbers would anyway. So that's the reason why I'm standing by that part of it. The other thing about it is that what I did here, the accuracy of the pressures coming out of the gauge in this A to B part of it isn't as important as the repeatability of it. If it's the way I think it is, and that the P cylinder, that we showed that equation before, the P cylinder equals the pressure to unseat the spring plus the pressure in the gauge. So basically, my position here on these compression tests is that they were all shifted down by the pressure of the spring. But what's important here isn't so much what the pressure actually was, it's more, did the pressure change from here to here? The fact that this problem happened takes away from the test a little bit, but what I'm looking at here is it's more about how much the numbers changed and less about what the numbers actually were. So I'm looking for a difference from here to here, not knowing exactly what the pressure in the cylinder was. I needed to know the difference. I think that part of this is still valid. So anyway, that's all I have to say about that. I wanted to follow up on these pressures because, I mean, I was honestly about ready to pull that engine and have a board and hone because I thought it was so bad. But turns out I just had a problem with my, my compression tester. So now what I want to do at the end of this video is I'm gonna just use this column here. I'm just gonna clear that out, and then we'll do the compression. I'll go through and do a compression test on these cylinders with the compression tester working the way it should. So let me go do that. Okay, so I just went through and did the compression test again with the compression test gauge fixed. So those compression numbers I am completely fine with, and in fact I think they're really pretty good. And these numbers up here in the brown are, I just went through and did the compression test the second time with the brand new compression tester and got very similar results. Anyway, I just went back through and put all the spark plugs back in and got the thing ready to run again. So hopefully next time I see you, we'll be doing a baseline run on this. Now the problem that I can see coming a mile away is that I'm going to have problems with that darn absorber and the way I'm controlling it. It does pretty well at lower speeds, but after I get close to 5, it kind of runs off. So I'm going to have to fight through that, but hopefully we can get ourselves some good data next time I see you. Anyway, that's all I got for this week, and I'll see you next time.